In today's video, we'll be solving exercise questions from Chapter 2 Acid, Bases and Salts of CBSE Class 10 Science. In page number 34, the first question asks us that a solid turns red litmus into blue. Its pH is likely going to be 1, 4, 5 or 10. So we know that a solution that turns red litmus to blue is basic in nature. So the pH has to be above 7. And the only option with a pH above 7 is option D. So option D 10 is the correct answer. Second question asks that a solution reacts with crushed eggshells to give a gas that turns lime water milky. What does the solution contain? NaCl, that is sodium chloride, HCl, that is hydrochloric acid, LiCl, lithium chloride, or KCl, potassium chloride. We know that eggshells are made of calcium carbonate. And calcium carbonate only reacts with acids and not with neutral salts like NaCl, KCl or LiCl. So the correct answer is that it reacts with HCl and it produces carbon dioxide gas, due to which the lime water is turned milky and the formation of calcium carbonate precipitate is seen. The equation can be written as CaCO3 plus HCl gives us CaCl2 plus CO2 plus H2O. The next question asks 10 ml of a solution of sodium hydroxide is found to be completely neutralized by 8 ml of a given solution of hydrochloric acid. If we take 20 ml of sodium hydroxide and the amount of HCl solution that is required to neutralize this will be 4 ml, 8 ml, 12 ml or 16 ml. So when it comes to neutralization reactions, we know that they always happen in a fixed ratio. So if 10 ml needs 8 ml, then 20 ml will need double that amount. So required HCl can be written as 2 into 8, which is 16 ml. Option D is the correct answer. Which one of the following types of medicines is used for treating indigestion? Antibiotic, analgesic, anti-acid or antiseptic? So we know that indigestion is caused by excess acid in the stomach. Basic substances such as antacids are used to neutralize the excess stomach acid. So option C, antacid, is the right answer. Fifth question says, write word equations and then balanced equations for reactions taking place when dilute sulfuric acid reacts with zinc granules, and 3 other equations are given. Let's start with the first one. When dilute acid reacts with zinc granules, that is metal plus acid is going to give salt and hydrogen gas. The equation for it can be written as zinc plus sulfuric acid gives zinc sulfate plus hydrogen gas. Zn plus H2SO4 is going to give us ZnSO4 plus H2. Equation for hydrochloric acid reacting with magnesium ribbon can be written as magnesium plus hydrochloric acid gives the salt magnesium chloride and hydrogen gas. Mg plus 2HCl gives us MgCl2 plus H2. The third one is dilute sulfuric acid reacting with aluminium powder. Aluminium plus sulfuric acid is going to give us the salt aluminium sulfate and hydrogen gas. So I can write this as 2Al plus 3H2SO4 gives us Al2SO4 taken thrice plus 3H2. Finally, we have dilute hydrochloric acid reacting with iron fillings. That is, iron plus hydrochloric acid gives iron chloride plus hydrogen gas. Fe plus 2HCl gives us FeCl2 plus H2. Sixth question says, compounds such as alcohols and glucose also contain hydrogen but are not categorized as acids. Describe an activity to prove this. So we can start by setting the conductivity apparatus. We pour distilled water into the beaker and insert electrodes as shown here. When we do this, the bulb does not glow because the pure water does not have any conductivity. Second, we can set up the same conductivity apparatus, but we can use dilute HCl instead of water. The bulb then glows, showing that this hydrochloric acid has ionized in water and conducted electricity, releasing H plus ions, which is a proof of acidic behavior. To test again, we can use glucose solution instead of hydrochloric acid solution. So when we do this, the bulb does not glow, showing that H plus ions are not being released by this glucose solution. And if we repeat the experiment with alcohol such as ethanol in water, the bulb does not glow again, proving ethanol does not ionize to produce H plus ions. Seventh question says, why does distilled water not conduct electricity whereas rainwater does? So if we conduct the same experiment as before and we see that the distilled water or pure water is not conducting electricity because it is not containing any ions. Electricity needs ions for its flow. So if we take rainwater, it has dissolved gases like carbon dioxide from the air which form weak acids like carbonic acid. These acids then produce ions, allowing the current to pass through the water, and we can see by repeating the previous experiment the bulb with rainwater glows. Why do acids not show acidic behavior in the presence of water? We know that acids release hydrogen ions only when dissolved in water. In pure form, for example in a gas form, they do not have free ions. So water acts as a medium that allows this acid to break apart. That's why they ionize only in water and they do not show this acidic behavior in presence of water. For example, hydrochloric gas without any water does not show any ionization. However, the same hydrochloric acid in water breaks into H plus and Cl minus ions, displaying acidic behavior. In the ninth question, we are given 5 solutions A, B, C, D and E, and they are tested with a universal indicator as shown in the figure here, and they are showing different pH levels of 4, 1, 11, 7 and 9 respectively. Which solution is neutral? So we can see that the neutral solution has a pH of 7, which is B. Which one is strongly alkaline? So the strongly alkaline one we can see here is C, which is in the bottom of the alkaline on the pH strip. Strongly acidic. Which one is strongly acidic? The solution that is on the top of our pH scale is the strongly acidic one, which is B. Which is weakly acidic? So the one with 4 as pH is weakly acidic. Weakly alkaline is the last one, which shows just below the neutral in the alkaline scale at 9. If I have to arrange these pH in increasing order of hydrogen ion concentration, I should know that hydrogen ion concentration decreases as the pH increases, because acids release hydrogen ion, so they are on the top and they have lower pH. As we are going down, the pH is increasing. So I can order as C, E, D, A and B. 10th question says equal lengths of magnesium ribbons are taken in test tubes A and B. Hydrochloric acid is added to test tube A while acetic acid is added to test tube B. Amount and concentration taken for both acids are same. In which test tube will the fizzing occur more vigorously and why? So we know that hydrochloric acid is a strong acid and it's going to release more H plus ions compared to our weak acid, which is acetic acid. So more H plus ions results in faster reaction, that results in vigorous fizzing. So as we can see in the figure, the magnesium ribbon which is treated with hydrochloric acid releases more bubbles and vigorous fizzing. Next question says fresh milk has a pH of 6. How do you think the pH will change as it turns into curd, and explain your answer? So I know that fresh milk has a pH of 6, which is slightly on the acidic scale, but when it's set into curd, lactic acid bacteria, that is our lactobacillus, it converts the milk sugar into lactic acid. So what's happening? The acidity is increasing even more. So it's going to shift our acidity. So it's around 4.5 to 5. So the pH is going from 6 to 4.5 or 5. Next question says a milkman adds very small amount of baking soda to fresh milk. Why does he shift the pH of this fresh milk from 6 to slightly alkaline, and why does this milk take a long time to set as curd when compared to the fresh milk? So what milk is slightly acidic, so it has a pH around 6. Baking soda on the other hand is a mild base. When this mild base is added to my acid, the pH slightly shift towards alkaline. So this is done in order to prevent milk from spoiling quickly. Because the milkman has to transport the milk from one place to another, the acidic condition of the milk might promote souring of the milk quicker. So he adds a pinch of baking soda to it. And the formation of curd has the mechanism where we need lactic acid bacteria that converts lactose into milk to lactic acid. This usually happens by lowering the pH. However, the milk to which baking soda was added has a slightly higher pH, or it is slightly alkaline. So we need more acid in order to turn it into curd. So more acid is needed to reach the pH where curdling happens. Question number 13 says, plaster of Paris should be stored in a moisture proof container. Explain why. So we know that when POP or plaster of Paris comes in contact with water or moisture, it reacts to form gypsum. The equation can be written as CaSO4 half H2O plus 3/2 H2O gives CaSO4 2H2O. Now this reaction happens where the plaster is turned hard and it's set into gypsum. It cannot be used again for molding or casting. It loses its effectiveness and shelf life. That's the reason we store it in a way where it doesn't come in contact with moisture so that it can retain its usability. 14th question asks us, what is a neutralization reaction, and give us 2 examples for the same. A neutralization reaction is a chemical reaction when you react an acid and base and the resultant products are salt and water. It usually involves the combination of H plus and OH minus ions to form water or H2O. One example is hydrochloric acid and sodium hydroxide turning into sodium chloride or table salt and water. Another example is sulfuric acid and calcium hydroxide giving us the salt calcium sulfate and water. 15th question asks us to give 2 important uses of washing soda and baking soda. Washing soda is sodium carbonate Na2CO3. This is usually used in laundry or to remove stains or to soften your hard water when you wash clothes. It is also used in glass, soap and paper industries as a raw material. On the other hand, baking soda is also called sodium bicarbonate and it has a formula NaHCO3. This is used in cooking as a leavening agent. This makes bread soft and fluffy, and it is also used as an antacid in order to relieve indigestion and heartburn. With this, we have come to an end to chapter 2, acid, bases and salts.